In our last video, we have set up TrueNAS on Proxmox. But now what? TrueNAS is up and running, but right now it's just an empty system with no usable storage. The drives are connected, but they are not doing anything yet. To actually store files or set up network shares, we need to configure our storage properly. But here's the challenge: TrueNAS gives you a lot of options, and if you're setting this up for the first time, terms like storage pools, datasets, and Zvols can feel overwhelming. Which one do you actually need? And how do you set it up for speed and reliability? That's exactly what we'll cover in this video. Step by step, we'll create a storage pool, organize our data using datasets, and set up Zvols for block storage. By the end, you'll have a properly configured TrueNAS system that's ready to use. So let's get started. I've already logged into TrueNAS dashboard. First, we need to check if TrueNAS recognizes our disks, which we have attached in the last video. For that, let's click on Storage from the left sidebar. This will take us to the storage dashboard. Here, click on the Disks button in the top right corner. Here, we can see a list of 3 drives. The first one is the boot drive for TrueNAS, while the other 2 are the 500 GB hard drives, which we passed through earlier. Since these are the drives we'll be using for storage, the next step is to create a storage pool. A storage pool in TrueNAS lets us combine multiple drives into a single, managed storage unit, improving both performance and redundancy. Now that we've confirmed our disks are detected, let's return to the storage dashboard and start creating our pool. On this dashboard, click on the Create Pool button. This will open the Pool Creation Wizard, where we have different segments to fill in. However, sections 3 to 7 are optional, so we won't be covering them in this video. Let's start with the General Info section. Here, we need to provide a name for our storage pool. I'll name it HDD500, which will help me to easily identify it later. There's also an option to encrypt the pool, but keep in mind that enabling encryption will consume more system resources. Since this is for my home lab setup, I don't need encryption, so I'll leave it disabled. Now let's click on Next. In the Data section, we need to choose a layout. This determines how the disk will be configured. The selection depends on resource availability and specific requirements, so you can set it up based on what works best for your setup. Now let's quickly go through what each of these storage layouts does. First, we have Stripe, which also known as RAID 0. This setup takes all the disks and combines them into one large storage unit. It gives you maximum storage capacity and speed, but there is no redundancy at all. If even one disk fails, all data will be lost. That means this setup is only good for situations where speed and capacity matter more than data safety. Next, we have Mirror or RAID 1. This setup stores identical copies of data across 2 disks. If one disk fails, the other one still has all the data, so nothing is lost. But since everything is duplicated, you only get to use half of the total storage capacity. For example, if you have 2 500 GB drives, you'll only have 500 GB of usable storage. This is a great option if you want simple and reliable data protection. Then there's RAID Z1, which is a more balanced approach. This setup requires at least 3 disks and can handle the failure of one disk without losing any data. The system will rebuild the lost data when you replace the failed disk. However, you will lose the capacity of one disk for redundancy. So if you have 3 1TB drives, you'll get only 2 TB of usable storage. If you want even more protection, you can go with RAID Z2. This setup needs at least 4 disks and can survive the failure of 2 disks at the same time. But since it uses 2 disks for redundancy, your usable storage will be the total capacity of all your drives minus 2. This is often used in setups where data safety is a bigger priority. For even higher redundancy, there's RAID Z3. This one requires at least 5 disks and can handle up to 3 disk failures. But that also means 3 disks worth of storage is used for redundancy. This level of protection is mostly used in enterprise setups, where data loss is not an option. So the right choice depends on how many drives you have and how much data protection you need. I won't be covering DRAID setups in this video, but if you're interested, you can always explore more about them. We will not cover the concept of how it works in this video. But if you want to know more about this, let me know in the comment section. For my setup, you can see that I have 2 unassigned disks, which means I can't use any of the RAID Z configurations. So I'll choose the mirror option. As soon as I choose mirror, the unassigned disks are selected automatically. This setup provides some level of security. If I lose one of these disks, I can still recover my data. Even though I have two 500 GB hard drives, my total usable storage will only be 500 GB, or slightly less, because the same data will be duplicated across both disks. On my other system, I have three 1 TB hard drives, where I use RAIDs 1. In this setup, even though I have 3 TB of total storage, only 2 TB is usable, since TrueNAS reserves 1 TB for parity. But ultimately, you can choose whatever configuration works best for you, based on your storage availability. Once we select the layout, TrueNAS will automatically assign the disks, moving them from the unassigned list to the configuration preview. This process usually works fine, but if you have a mix of different disk sizes and want to select them manually, you can do so under Advanced Options in the Manual Disk Selection. Now if you focus on the Automated Disk Selection section, it's showing a width of 2, which means it will use both disks to create a single VDEV, exactly what we need for this setup. As I mentioned earlier, sections 3 to 7 are optional and meant for advanced setups, so we will not be using them in this video. Instead, let's click on Save and go to Review. Here, you'll see a summary of your selected configuration. If needed, you can inspect your VDEV once again. In TrueNAS, a VDEV or virtual device is just a group of disks that work together as part of a storage pool. Once everything looks good, click on Create Pool. Then just check the confirmation box and click on Continue. TrueNAS will now start creating the storage pool. Once completed, you'll be automatically redirected to the storage dashboard, where you can view all the details of your newly created storage pool. Now it's time to create datasets. To do that, navigate to Datasets from the left side panel. In TrueNAS, a dataset is just a way to organize and store different types of data separately. On this page, you will notice that a dataset has been already created with the same name as the storage pool. This is actually the parent dataset. From here, you can create multiple datasets, each with its own permissions and access settings. This flexibility is useful for organizing data, restricting access, or even setting up network shares based on specific needs. To create a new dataset, click on the Add Dataset button in the top right corner. This will open the Add Dataset form. Here, we need to simply enter a name for our dataset. I will create this one for my personal files. Once done, click on Save, and the new dataset will be created. Now let's create two more. One for work-related files, and another for team collaboration. To do that, I will select the parent dataset and click on the Add Dataset button. Let's repeat the same process for the second one. This way, we can organize different types of data and assign specific permissions to each dataset, ensuring the right people have access. We can even take this a step further by creating nested datasets. Under my personal dataset, I will add two nested datasets, one for documents and another for media. This helps keep things structured and easy to navigate. I would also like to set up a dataset specifically for my VM storage. Within this, I'll set up a nested dataset for NFS sharing to access the VM files. But when it comes to databases, we require block storage for better performance and reliability. In TrueNAS, there are two primary storage types, Dataset and Zvols. While Datasets store files, a Zvol works more like a hard drive, making it a better choice for things like databases or virtual machines. To create a Zvol in TrueNAS, we can use the built-in iSCSI sharing feature. The process is simple. Just select the dataset where you want to create your Zvol. Then click on the Zvol button in the top right corner. This will open a form. Here we need to specify a name for it. Then define the size. Once that's set, click on Save, and the Zvol will be created. One advantage of using Zvols is that we can increase their size anytime if needed. Like, I want to expand it from 10 gigabytes to 15 gigabytes. To do that, I will simply click on the Edit Zvol button and increase its size to 15 gigabytes. Then click on Save. As you can see, now the size has been increased. But if we try to reduce it, we will get this error stating that shrinking a Zvol is not allowed, as it may cause data loss. Now that we have successfully created our storage pool and datasets, the next step is to make them accessible by setting up a network share and configuring user permissions. In the next video, we'll walk you through the entire process step by step. Make sure to watch it to complete your setup and start utilizing your storage effectively. If you found this video helpful, don't forget to like, share, and drop a comment below about the best part. See you in the next one.